In this video, we are going to explore what software engineering actually means and why it's not the same thing as programming. This distinction matters, especially now that AI tools can generate code for us. Understanding where software engineering came from helps us understand why certain practices exist and why they still matter today. Let's start with a fundamental distinction. Programming is about writing code so a computer can perform specific tasks. Software engineering is broader. It's about creating systems, applications that are dependable, reliable, usable, safe, and secure. Software engineering also involves working in teams, managing projects over time, solving real problems for real users. Being a skilled programmer doesn't automatically mean you can build large working systems. History has taught us this lesson repeatedly. In the early days of computing, the 40s and 60s, most software was built by small teams or even individuals, and typically for a specific hardware. But as organizations started depending on larger and larger systems, like operating system, airline reservations, defense software, problems kept showing up. Projects ran late and over budget, delivered systems were unreliable or difficult to change, and perhaps most troubling, maintenance cost often exceeded the original development cost. These weren't isolated incidents. They were a pattern. Software engineering emerged as a response to this problem. The idea was to apply concepts from traditional engineering, things like requirements gathering, design, verification, to software development. Instead of treating software as just a pile of code, we needed to treat it as a design system. This meant focusing on process, documentation, and teamwork, and not just clever algorithms. By the late 60s, these problems were so widespread that people gave them a name, the software crisis. Projects chronically overran their schedules and budgets, systems failed in the field or were never completed at all, software couldn't be reliably maintained or extended, and there were larger gaps between what users actually needed and what systems delivered. The crisis wasn't caused by lack of a skill among developers. It revealed something more fundamental. Building large systems requires very different methods than writing small programs. The techniques that work for one person writing a few thousand lines of code simply didn't scale. In 1968 and 69, the NATO Science Committee held two important conferences. 1968 conference in Germany brought together researchers and practitioners to discuss these problems. The term software engineering was deliberately chosen to be provocative, a provocation, to push people into thinking of software development as an engineering discipline rather than an informal craft. The 1969 conference in Italy continued the conversation and highlighted communication gaps among researchers, managers, and practitioners. These meetings didn't solve everything overnight, but they marked a turning point. The field agreed that software should be developed with an engineering mindset. Starting in the 70s, software engineering began developing its own methods, artifacts, and practices. We got structured programming, object-oriented design, and later agile and DevOps. We formalized artifacts like requirements specification, design documents, test plans, and we established practices like code reviews, configuration management, and quality assurance. The goals of software engineering are often summarized in these 5 objectives. Dependable means the system does what it's supposed to do consistently. Reliable means it works correctly over time, even under stress. Usable means people can actually use it effectively. Safe means it doesn't cause harm. And secure means it resists unauthorized access and attacks. Achieving these goals takes more than clever algorithms. It requires a good process where teams gather requirements, make design decisions, verify correctness, deploy carefully, and maintain systems over time. Now you might be wondering, why does this history matter now that AI tools can generate code, write tests, and suggest designs? Here's the key insight. The hardest part of software engineering has never been just writing code. The real challenges are working together, communicating clearly, managing complexity, understanding what users actually need, and making sure systems work well for people who didn't build them. AI tools can help you build things faster, but you still need clear requirements, good design, careful testing, and safe deployment. In fact, if your goals aren't clear, AI can make mistakes happen faster because it can generate incorrect code more quickly than before. The practices that emerged from the software crisis aren't relics of the past. They are still essential today.